Well, hello and welcome to our eOrganic webinar. Today we will be hearing from Drs. Heather Darby and Andre Brito, who will be sharing research on growing flax and feeding flaxseed to organic dairy cattle. My name is Deb Haliba and I work at the University of Vermont Extension as eOrganic's Dairy Team Coordinator. eOrganic is the organic agriculture community of practice with e-extension, and you can find all of our published articles, videos, upcoming and recorded webinars at eextension.org/organic_production. Today's webinar has funding support from the USDA NIFA Organic Research and Extension Initiative. If you do plan to share the recording or the information presented today with others, we'd greatly appreciate acknowledgement of our speakers as well as eOrganic. And before we get started, I wanted to give a quick overview of today's agenda. Our session today is scheduled to end at 1/4 the hour. Heather and Andre will provide their presentations for about 50 or so minutes, and then we'll spend our rest of our time together with a Q&A session with our speakers. Okay, now it's my pleasure to introduce today's speakers. We have Dr. Andre Brito, who is an associate professor in the Department of Biological Sciences at the University of New Hampshire, where he focuses on dairy organic management. Andre currently leads the USDA OREI project called Assisting Organic Dairy Producers to Meet the Demands of New and Emerging Milk Markets, which is funding the research he will discuss. We also have Heather Darby, who's a professor of agronomy at the University of Vermont Extension, where she conducts applied research and farmer outreach on a number of topics, including farm-based fuel, cover crops and soil health, nutrient management, organic livestock forages, and grain production systems in the Northeast. So today, Heather will be speaking first, and so we'll just turn the mic right over to her. Thanks,
Great.
Heather.
Thanks, Deb, and welcome everybody to the webinar this afternoon. I'm going to start the presentation off by talking about growing flax and my experiences doing that in the northeastern part of the United States, and also under, obviously, organic management. Now, for those of you who are not familiar with flax, it's in a unique plant family. We don't grow a lot of, or any other crops that I know of, that are in the Linum plant family, and therefore it actually makes a great crop in rotations because it does break up plant family cycles when you're rotating, but it's not commonly grown in the Northeast. There are very few farmers that I know that are growing flax or have grown flax, and most of the flax today is grown in the western part of the United States, primarily in western Canada. Flax is a spring annual crop, and again, it's a cool season crop. It generally gets planted here anyway in April or very early May. It's got a relatively short growing season to maturity, 90 to 100 days required. It stays in a vegetative period for about 45 to 60 days. And then it flowers over quite a long period of time. It has indeterminate flowering, so it continues to flower from 15 to 25 days. And then it takes around 30 to 40 days for the plants to mature. So here in the Northeast, if we're planting in April, we're generally harvesting towards the end of July, very early August. So flax is primarily grown or being grown as an oil seed, but many of you may remember the days of flax or linen clothing. I guess I don't own any of that because it requires dry cleaning, but it's a very nice textile that's used to make high-end clothing today, but it's not really grown that much for clothing anymore or for textiles. It also was used to make ropes and materials like that. Really during colonial times, it was very popular for those purposes. Now today, a lot of flax is primarily grown for oil. So the seed is harvested, and it contains about 40% oil by weight. And the really unique aspect of the oil that is contained in the seed is that it's really high in alpha-linolenic acid, which many of us also know as the omega-3 fatty acid. And I think probably just saying that rings a bell for many people who are purchasing high or foods that are high in omega-3, milk that's enhanced with omega-3, or eggs that are enhanced with omega-3, or maybe you're actually even taking a fish oil supplement or a flax oil supplement to increase the level of omega-3s in your diet. For those of you who don't know, that we don't actually make omega-3s ourselves, which is why we need to consume them in our diet. They are an essential fatty acid. Andre will probably talk more about that. So today a lot of flax is being grown for the oil content and for the meal, oil going primarily into the human market, and the meal being used to feed animals to increase the amount of omega-3s in their subsequent products. So again, I'm going to focus on producing flax, and I have to say I'm not an expert. I have probably about 5 years worth of growing experience, and I finally feel like maybe I've figured it out. So I can definitely tell you about all the challenges with growing flax. But there is a wonderful publication that was developed by Kathleen Dellett, who many of you know at Iowa State, and several of her colleagues, and it's a publication on organic flax production, and I put the website here for you to go to, and it's a very applied article and covers much of the stuff that I'll talk about today. So it's a good resource for folks, especially those out in the field. The next thing I'll just touch on is yields of flax, just to start with that. Now, commonly, the yield of flax is between 1,200 and upwards of 4,500 pounds per acre. I know Iowa State reported 4,500 plus pounds per acre under organic production, but I would say the average really that most people are shooting for is about 1,200 to 1,500 pounds, with a ton feeling like a very good yield. And there's a lot of influences on the yield of flax. Just like any crop, the variety has an influence on the yield, the rotation that you're using, the climate that you're in. It is a cool season crop, and it is very sensitive to heat, especially during flowering, so that can impact yields. And then certainly many other factors that we've come up against, primarily weed pressure, trying to target the right planting date for this area, and the harvest strategy. Flax is very challenging to harvest, and once you sort of come over, I guess, overcome some of these barriers, the yields can be very good. And we here in Vermont have seen yields well over 1,000 pounds, but everything has to be just right for us to optimize yields here. All right, so just briefly about the soil requirements for flax. Like most crops, it likes a slightly acidic pH between 6 and 6.5. It's not really a big plant. It doesn't require a lot of nutrients, about 50 to 70 pounds of nitrogen per acre, and anywhere from 20 upwards to 60 pounds of phosphorus and potassium. But really, you know, to understand what the crop actually needs, you need to do a soil test. But those are just rough ranges that we have found for flax production. And of course, you know, one of the sort of major requirements for flax that I probably will emphasize over and over again in this presentation is that it really needs to be in a good crop rotation. And when I say that, because it doesn't require a lot of nutrients, you might think that the best place for flax in a rotation is after a crop that does require a lot of nutrients, so maybe following corn or even, potentially following soybeans. But flax is very, very sensitive to weed pressure, and so, we really have to follow a rotation that absolutely minimizes weed pressure before you grow this crop. So variety selection I'll talk about first. We have trialed multiple varieties over a number of years, and we do see some difference in yields. I would say the first few years that we trialed varieties, we honestly were just trying to figure out how to grow this crop and really had some significant challenges with harvesting. So our data really isn't the best here. But when you're thinking about variety selection, really there's kind of two types of flax. There's flax that is really has been bred for the fiber, and most of those flax types are brown flaxes, and so you'd be looking for a fiber variety, not necessarily one that produces oil. And then there is another type of flax that's called like high omega flax or golden flax, and those are varieties that have been bred to produce higher amounts of oil and higher levels of omega-3 when the seed is extruded. So there's a couple of choices there, brown flax or golden flax. Generally the golden flax is going to be really high in omega-3s. We found that it actually yields a bit lower than the brown flax, but overall all of the flax types do produce some oil, but it really depends what your market is. We haven't seen too much disease here in the Northeast, but sometimes we'll see a little bit of rust, so looking for rust resistance is good. And then obviously purchasing organic seed, if you're certified organic, is a requirement, and that can be also challenging. So we've trialed a number of varieties, and you can see here's some data from last year. And I guess what I want to point out again is that flax is really not a very robust plant. It really only grows to be about 1 to 3 feet tall, and it has small little leaves, so it again is not very weed competitive at all. And this is really something you have to consider if you're thinking about growing this crop. These are varieties that we secured primarily from folks in North Dakota. One that is really widely available through places like Albert Lee Seed House in Minnesota that I believe is also certified organic is Rahab. And you can see that our yields over here were pretty low last year, and primarily that was a result of poor harvest again, and I'll talk about this more. But you can see some difference in the varieties. There was nothing statistical. They were all pretty low, but several of them approaching nearly 1,000 pounds per acre, which is our goal is about 1,200. But again, some challenges with harvesting. Okay, just a different pictorial view. Okay. Flax variety trial quality results. And as part of our project, we were looking at oil content, and the oil content of these different varieties extruded with a cold press that could be purchased by a farmer or a small local business. So this press in particular is a Kernkraft press out of Germany. And you can see there is a difference in the oil content, the percent oil content in the different varieties. And again, if you're after high oil types, you'll definitely want to be looking at this type of information. And you can see that Gold and Tacoma and Cathaway were all quite a bit higher than some of the other varieties. Some of the other components we're looking at in the flax oil is free fatty acids and soluble impurities and iodine value. And really, mostly these values are indicators of stability of the oil, and the higher the level of free fatty acids, actually often the more stable the oil actually is. Here's just a different view of that information in a graphic view of the percent oil and free fatty acids. We'll talk a little bit about planting flax. So as I mentioned before, this is a cool season crop. It's very similar to spring grains, which is a common crop here in the Northeast. And we want to plant flax about the same time as we plant spring grains. We found the best planting dates to really be the end of April. You really need to have a well-prepared seed bed because this is a very small seed. I think most of you have probably seen flaxseed before. It's only planted about 1/4 inch deep and maybe even more shallow, really depending a little bit on the soil moisture. We seed commonly about 50 to 55 pounds of seed per acre but seeding rates range anywhere from 50 to 70 pounds, depending on where you live. But we've commonly seeded with 50 to 55 pounds. Again, it's shallow planted, and it's really small seeds, so you want to have a very fine and well-prepared seed bed. Sometimes we plant very shallow and then we go back over the field with a cultipacker just to push it in just a little bit. Here's some data from a planting date trial that we harvested last year, and we've done this for a few years in a row. And you can see again, like I mentioned, that planting in April really gives us the best yields. Again, our yields are low, and I'll talk about that as I mentioned, but higher than the May planting date. So we've already planted our flax for this year, and I think we had it planted by the 20th of April. So that's really our goal, to be planting about the same time as spring grains. The other piece you'll notice is that when you plant earlier, this wasn't statistically significant, but often when you plant earlier, the crop gets out of the ground, growing faster, and a little bit better to be able to outcompete weeds. And just, again, a different view of the data, again showing that the April planting dates yielded the best for us. You can also see that planting date did have an impact on the amount of oil, and really the April planting dates also allowed for better oil production in the seed. And this is pretty common. We've seen this in other data from around the country as well. So proper planting time does influence oil content in the seed. And again, this is just a different view of the data, so you can see it pictorially. I want to talk about weed control. I've mentioned it a lot. It's probably been our biggest barrier besides harvesting to flax, producing flax in the Northeast. And for all the farmers that I've worked with, it's been the same challenge for them. There's a lot of practices that we already all know about to help minimize weed pressure in crops. But for this crop, again, you can see how short it is. It hardly has, it's got these tiny little leaves. It's just not a crop that canopies, so it's really prone to weed pressure. So, the number one thing that we've really emphasized with farms is rotation. And here in Vermont, what we've found that works best is actually to grow flax coming out of a sod crop, where we already know the weed pressure is going to be really low after being in a sod crop for at least 5 years. That's really going to be a situation where we have very low weed pressure. And that actually, for us too, on our research trials, that's when we've produced the best flax yields with the lowest weed pressure. So the rotation piece is key. And I know in Iowa State, they've seen similar things. When you're coming out of corn or a crop that is prone to generally having some weed pressure, and then you follow that crop with flax, you're sort of setting yourself up for disappointment. So just recognize that. Interseeding is a practice farmers are using, or underseeding, and I'll mention that as we go along. Row spacing is a practice we've used. Seeding rate, we haven't dabbled in that too much. I'm not sure how much of a difference that'll make. And then cultivation, and I'll talk about that as well. Okay, so through this project, we've actually looked at different ways to control weeds in flax over a couple-year period. And these are the different treatments that we used. We actually used a narrow row treatment, planting flax in 4.5-inch rows versus the kind of standard 6.5-inch, okay, with no cultivation. We also used a wide row planting system where the rows were 9 inches apart, and then we went through and cultivated between the flax rows with a tool called a Schmatzer hoe. And then we also use standard 6-inch row spacing, tine weeding the flax, underseeding or interseeding the flax with clover, or doing nothing at all. And we did this over a two-year period. So this is a picture of the narrow row. This is in grains. These photos are from Dr. Ellen Mallory at the University of Maine. Ellen and her husband, Eric Gallant, at the University of Maine, also brought this technology into the Northeast out of Europe, and so we've utilized it as well. This is a cavernolin drill that set up the plant on 4.5-inch rows. And this is just a picture of barley growing in 4.5-inch rows. And then the next photo is utilizing this same drill, but blocking off every other hole to create 9-inch rows. And then using a cultivator, and most people use guidance systems to do this, to cultivate between the flax rows. Now we're going on to the next slide that shows me actually cultivating flax with this Schmatzer hoe. And this is a research unit, so you can see somebody actually sits on the back and steers it. It's actually quite a lot of fun over a very short period of time, but it gets a little wild when you're staring at the ground for a long period of time. So it's perfect for research, but I just wanted to show you what the cultivating tool looked like. Okay, so this is the wide 9-inch rows of flax before cultivation, and then this is the 9-inch rows after cultivation. So you can see the cultivator. So you can see the cultivated flax, and you can see it does a really good job removing the weeds, especially if you catch them right at the right time. And if we go to the next slide, just shows another view of the cultivated flax. So this is actually a tool that's primarily been used in grains, but now we're utilizing it in other crops that aren't traditionally cultivated under organic systems. So we're going to be using this in soybeans and some other crops this year. Shows a harrow or a tine weeder. Many people are familiar with this tool, so we've used this in flax as well. The issue with using a tine weeder in flax is that you have to wait for the flax to be fully emerged, growing really well and well anchored before you can run this tool through it, because it's seeded so shallow. And usually by that time the weeds are too big, and so it hasn't really proven to be an effective tool, and I'll show you that in a second. So this was from 2013. And it shows you pictorially the control plots. You can't really see the flax in there, the narrow row plots, and the wide row with the Schmatzer hoe. And you can actually make out the flax in the narrow and the wide row, mostly in the wide row. You see a lot of weeds along the edge. Those are other plots. So you can see how weedy this crop can get. And you can see with a tine weeder, we only removed about 20% of the weeds, but with the Schmatzer hoe, we were actually able to remove about 80% of the weeds. And really, this was the difference between a harvestable crop and a not harvestable crop. So you can see a wide row flax with cultivation. We had the highest yields, about 600 pounds in this year per acre, and we also had good or harvestable yields from the narrow row flax. We did harvest the control plots. We didn't harvest any of the other plots because it was so difficult to harvest. We did harvest the control because we wanted to see at least what the control yielded, and you can see it was only a couple hundred pounds. And we also measured the weed cover, and you can just see 40% of the plot in the control plot was weeds. So again, this gets back to managing weeds in flax is absolutely necessary if you want to get a crop, and it's not that easy to do. This is from 2014, and in 2014 we actually had planted the flax into a field that had been out of sod for 2 years, and the prior crop to that was a cover crop. So what I want you to notice here is that the weed pressure in general was lower. And no matter what kind of tool we used, we were able to remove most of the weeds there. It was a more ideal situation, low weed pressure to begin with, and irregardless of what we used, a tine weeder or a Smotzer hoe, we were able to remove a significant amount of the weeds. Okay, and also in 2014, here are the yields from 2014. You can see that the control plot actually didn't yield any differently from any of the other treatments. Okay, so really the take-home message here is that rotation and going or planting flax into or following a crop that has very low weed pressure is going to help you actually get a crop. It's going to help you be successful. And these other tools, the Smotzer hoe, narrow row planting, tine weeding, interseeding or underseeding, all of those practices help, but really they don't help if the weed pressure is high. Okay, and you can see in 2014 our yields were close to 1,200 pounds per acre. I'll just touch on underseeding. We've done a little bit of underseeding. Most of the research that has been done with red clover, and the recommendation is for 10 pounds per acre. And there's lots of value to putting red clover into the flax. The primary issue is that the red clover can outgrow the flax and can make it even more difficult to harvest. So people do use red clover, but again, it can add even more difficulty at harvest. I need to wrap up, so I'm going to go through the harvest challenges, which are actually pretty straightforward, and then we'll turn it over to Andre. So we're on the harvest challenges slide, and you can see up in the left-hand corner how beautiful that flax looks early on in the season when the kind of late season weeds haven't really kicked in yet. But you can see over here to the right some of those weeds filling in the stand. Okay, so the primary challenge with harvesting flax is the fact that it doesn't dry down evenly because it flowers over a long period of time. It is the stems itself don't dry down evenly either. So sometimes you have green stems and ready to harvest seed. And then you generally have weeds. So all of those factors make it really, really difficult to direct combine a crop. And in a research setting, it's really hard to have a way to swath the plots. We have these tiny little plots. And so we had been trying to direct harvest the flax and lost a lot of the flax trying to do so because of the weeds and the uneven dry down. All right, so you want to harvest the flax when 90% of the bolls, the little round seed pods, are brown, when the seed moisture is roughly 10 to 12%. And the crop doesn't shatter all that much, but generally flax is swathed because of the weed pressure. And you can see here this is the brown pods and here's the green stems. And that's really difficult to get through the combine. So we actually developed, or Roger Rainville that works with us, developed a swather to use in our research plots. And hopefully this is going to help us get a better yielding crop because we're going to be able to swath it. And you can see that it essentially cuts the width of our plots without running over plots, trying to swath. So hopefully we'll get better yields as well. I just thought I'd share this for any of the researchers out there that need something like this. Talk to me. We can show you how we built it. Pass the swather. Should say harvest. These are some more specific things about harvesting flax in terms of setting your combine. The other challenge we have with our Almaco combine is that it really does a poor job of harvesting flax. We can't set the concave clearance narrow enough. We can turn the fan speed down really low, which you need to, so it doesn't blow all the seed out of the back. But with some trash in the seed, it's hard to get the seed to blow up into the catch basement. So our plot combine isn't ideal for harvesting either, but with a commercial combine, you should be able to dial in the harvest a little bit better. And this is in the Iowa State publication as well. Next slide is just a picture combining the flax, direct combining. You can see the weeds. Just quickly about post-harvest handling. You definitely are going to have to clean the feed once you harvest because there's still a lot of trash in it even when you swath. And then ideally for long-term storage, you want the seed at 8 to 10% moisture. All right, so these reports and all the information are on our website, and I'm sure they'll post that as well. And just want to thank our funders that supported this work. And I will turn it over to Andre. Thank you very much.
Great. Thank you so much, Heather. So Andre, you're up next. If you could unmute your, there you go, and you can go ahead.
Sure. Well, thanks a lot, Deb, and the audience. So I will be talking, some of the application of what just Heather, said, and trying to showing some data on the impact of flax on on milk production and milk fatty acids. Yes. So this is just the motivation of the study. So this is a collaboration between University of New Hampshire, University of Vermont, the USDA ARS unit at University Park in Pennsylvania, University of Maine, and Cornell University. So back in 2012, 2011, we did a needs assessment of the research and extension in the Northeast, and a lot of dairy farmers, organic dairy farmers, were interested in value added as a way to capitalize on that market. It's well known the potential benefits of omega-3 fatty acids and CLAs for human health. We understand that would be a nice way to combine what farmers were looking for with the research that we had in mind. However, the opportunities to have year-round production of milk with high concentrations of omega-3 and CLAs are constrained by short grazing season in the Northeast. It's well known that pasture and high forage rations promote more omega-3 and CLAs in milk. And also, when the cows transition from pasture to the winter feeding by changing from pasture and now conserved feed, there is also less omega-3 on those on that feed. So we're trying to build on those opportunities and constraints. This is basically stakeholder research. We basically applying what farmers were interested in terms of research, and a multidisciplinary perspective because we're combining different fields from agronomic fields, modeling, economics, and also dairy nutrition. So this is the conceptual model of the project. We're looking at pasture ecology and management. We're trying to extend the grazing season, conducting research with animal crops, forage crops that will be available in the spring, summer annuals, and also forage brassicas and forage more towards the fall season, and also supplementing cows with flaxseed in the summer and also in the winter, and looking at animal health, production, methane emissions, and also milk quality, talking specifically here about omega-3 and CLAs, and also the profitability of that application. So flax, as Heather pointed out, it's an oil seed that's rich in energy, particularly high in fat and also in omega-3 fatty acids, as Heather mentioned, the alpha-linolenic acid. And a lot of research has been showing that those fatty acids can be transferred to milk. There's less research with ground flax, as I'll be showing here today. So in addition to this potential human health benefits, flax or ground flax has been shown also to reduce methane emissions, and I'll be sharing here some work that we have been doing here at UNH and also in Pennsylvania in the Cat Solders lab. So 2 experiments I'll be primarily showing here today. The first study was done, we used 20 organic Jersey cows. They receive incremental amounts of flax during the winter season in a replicated 4x4 Latin square design. Each period lasts 21 days, and then cows change diets. Experiment 2 was done during the grazing season. The experiment was done over the grazing season, was over 100 days. They study in which half of the cows receive flax, the other half received no flax, and the amount of flax fed was about 10% of ground flax in a randomized complete block design. Both experiments are conducted here at UNH. This is the view of the farm. We have about 40 acres of forest, 57 hectares for conserved feed production, about 20 hectares of pasture. We have a small herd, about 50 lactating cows, and you can see the fields that we use for for pasture, and also the fields like this one, field 1 here, that we use for forage production. Other fields that are also used for forage production. So this is just the part of this data has been published at the Journal of Dairy Science, so you can have access to that data, and I'll be sharing some of that here today. That's the typical nutrient composition of flax. So it's a good source, a relatively good source of crude protein, about 23% of the dry matter, but a very good source of fat, crude fat here with ether extracts, about 34% of the flax that we use here. And again, a very good source of alpha-linolenic acid. This is the omega-3. You can see about more than half of the total fatty acids found in flax was alpha-linolenic acid. So that's the diet that we fed. You can see we have this incremental amounts of flax from 0 up to 15% of the diet dry matter. And you can see the actual amounts of flax in pounds. It ranged from 0 up to 6 pounds a day. And basically was at expense of soybean meal. You can see that soybean meal decreased and corn meal also decreased in the ration. So we're trying to balance the rations for protein and energy. So all rations have similar levels. Because flax has higher protein and also high energy, we at the expense of soybean meal and corn meal, we achieve relatively similar levels, as you can see here, of crude protein and NEL. So you see the crude protein of the rations, it's almost like very similar, around 18%, and net energy of lactation of NEL increased from 1.6 to about 1.76. That was the best that we could do, considering that very high levels of fat that are that's present in flax. So the fat, as you'd expect, also increased from 3.8 to 7.35%. That's you can see that the levels of 5.73 and 7.35 are higher than is recommended for dairy rations. Dairy rations should be around 5% fat. Because of the motivation of the study here, we went above the recommendations. And the starch, as you can see, it drops from 19 to 11.5% of the diet because corn meal was reduced substantially, and flax is a poor source of starch. Alpha-linolenic acid, as you would expect, increased substantially as the amount of flax in the ration was increased from 0 to 15% of the diet dry matter. So showing some data now. First one here is the dry matter intake. You can see that as the amount of flax increased in the ration, dry matter intake dropped from 37 to about 35. That was a linear decrease. We're talking about here 2 pounds or so of less dry matter intake, and that could be as a result of the high levels of fat that was fed to those cows. We use the Kaelan gates to individualize intake. You can see here we are complying with the organic rules to have cows moving freely, in a barn. So you can see in the back, you can see the bedding area. The cows are going to move from that to a feed station where they have specific gates. You can see the yellow transponder where the cows basically are trained to open those doors, and then she will be specifically having access to that door. She cannot open any other door. So in this way, you can actually, measure intake on individually. So milk production follow dry matter intake. They follow close. You see a drop in dry matter intake. You also see a drop in milk production. And milk production decreased linearly from about 47 pounds to 44 pounds. Again, a drop of about 3 pounds, but primarily with the higher levels of flax, 10 and 15%. You can see that very clear. So talking about milk components, milk fat did not change at all. It averaged about 4.6% or so. However, the other components, talking about production of milk fat, it decreased linearly, and also the concentration and production of milk protein both decrease linearly with those high levels of fat or flax interaction, and MUN also decrease linearly. The decrease in MUN here could be potentially explained by the cows eating less protein. They have less dry matter intake, then they have less protein intake, or the protein from flax was better utilized than protein from soybean meal. The drops in concentration and production of milk protein could be related to elevated blood fatty acids, and that caused by the increased fatty acid intake that has a negative impact or effect on growth hormone, so less amino acid capturing the mammary gland of the cows, or reducing blood flow to the mammary gland because of those high levels of fat in the system in the blood. So those can cause milk protein depression, as we see here. Talking about specifically now about fatty acids, you can see that's, as you may expect, the concentration of CLA, it increased linearly, and there is also a quadratic response because, as you can see from the 10, from 15%, you have more of that increase. So, but overall, you have these upwards levels in terms of the both cis9 trans 11 in blue or the total CLA. The cis9 trans 11 is the most bioactive CLA that has more link to being potentially good for humans. And we have about 85 to 96% increase compared to the zero. You can see that even the 10 and 15% where you have the highest levels of the CLA and total CLA. So the omega-6 and omega-3s, the omega-6 in blue here, you can see that omega-6 decrease linearly, and while the omega-3s increase linearly and also have a quadratic response. In this case, the going from 0 to 5% caused the highest increase in omega-3, so that's why you have the quadratic response. But overall, you see upwards increase in omega-3 fatty acids. So that led to, a 94% increase compared to the zero level in terms of omega-3 and a 19% decrease. So combined, you can see that the omega-6 to omega-3 ratio decreased linearly and again quadratically, and again the more you see the greatest drop from 0 to 5%, and overall we have almost like 150% lower the omega-6 to omega-3 ratio with the highest levels of flax, almost close to 1. It's a little bit over 1. So if you think about what has been out there in terms of omega-6 being omega-6 to omega-3 should be between 2 and 1 as ideal. So you could see that milk is showing that. So in terms of methane emissions, we collect methane data. You can see the cows are equipped with this canisters in the back, and the tubing, basically, it will capture the gas that is being expired or the breath, and then the canisters, which is this PVC white tube, we basically change that a couple of times, evacuated that, and get the gas and inject in a GC or gas chromatograph, so we can measure methane using the SF6 or the sulfur extrafluoride technique. In terms of that data set, we saw this data is not being published. We're still looking at this data a little bit closer, but this is kind of preliminary data. You can see that as we fed more flax, there was a reduction in methane emissions. Again, this I will explain in a minute why could potentially cause this drop in methane emissions, but you can see that was a linear decrease when methane is expressed in grams per day. If you express methane in an efficiency base, or grams of methane per kilo or pounds of energy corrected milk, we saw also a tendency to decrease linearly methane emissions when cows are fed flax. Again, one of the reasons for that could be related to the rumen metabolism, of the rumen volatile fatty acids. We collect rumen fluid from those cows. You can see the figure here in the bottom, in the corner right, passing the tube to the esophagus of the cow, reaching the rumen. We're not allowed to use antibiotics, as you know, in inorganic systems, so doing surgeries not an option to have cows cannulated in the rumen. So this approach can be done. Of course, takes also lots of work to do this, but we're able to collect that kind of data. And you can see that the acetate, which is one of the volatile fatty acids, and propionate, most of the time when you have an increase in propionate, as you can see here, linearly from 14.4 to 16.4, in a decrease in acetate, so less hydrogens will be available for the microbes that synthesize methane, or the methanogens. So that could explain why methane emissions decrease when cows are fed flax. Another way also that could explain that was digestibility. This table here shows the apparent total tract digestibility. And as you can see, for all the variables that I'm showing here, dry matter, organic matter, and fiber, either neutral detergent fiber or acid detergent fiber, you can see that was either a significant linear effect as for dry matter, or trends for reduction in nutrient digestibility, and that could mean less fermentable energy in the rumen and less methane and less gas produced by the microbes. So that could explain also why cows had less methane emissions when they're fed higher levels of flax. We also collect data in trying to better understand the microbial population. Here again, this data is not being published as well, but you can see that the methanogens, or the microbes that utilize hydrogens and CO2 to make methane, all the species, not say all, but some of the species are shown here, and you can see the Methanobrevibacter, you see the population drop linearly when cows were fed flax. The other ones, that less proportion, but the Methanomicrobium and Methanosphaera, all of those also decrease linearly and also quadratically. That's showing that has an impact of levels of flax on the methanogenic population, which can also explain why cows produce less methane. We did a quick analysis here of the income over feeding costs. You can see that income over feeding costs decrease with the incremental amounts of flax in the ration, and that could be explained by the drop in milk production, and also because flax is quite expensive. I'm using data here from 1 year ago or so, the flax was about 1,400 per ton. So that's delivered from Minnesota here in the Northeast at Alfar. So that explains also, the income over feeding costs really drop when flax was fed. Changing gears here a little bit, so from winter to pasture feeding or summer grazing feeding. So this study was done by Kathy Solder at her lab there in Pennsylvania at ARS. We use an in vitro approach here. You can see those fermenters. Those are in vitro system that simulates rumen of a cow, as you almost like seeing there 4 cows, maybe if you make that effort. But the system are fed as you'd fed a cow a couple of times. In this case, a pasture feed, the system was fed 3 to 4 times a day. It was fed orchard grass as the major feed source, and also some flaxseed in incremental amounts as I show for the winter feeding. And you can see this data also, the rumen data. I'm sorry, the title of this slide, it's not correct. But the acetate, almost increase a little bit, but you can see the propionate increase also. That's an indication that less hydrogen is available for the methanogens microbes. And then when you see methane production, also either in amounts or as an efficiency base in grams of methane per grams of organic matter fed or digestible fiber fed, also decrease linearly, again emphasizing the effect of flaxseed on reducing methane emissions. And again, these were a simulated pasture-based condition with the fermenters or fed orchard grass as the only feed, and then replacing some of the orchard grass with flax. So moving now to the grazing study that we conduct here back in 2013. So we're looking at feeding flax over the grazing season and looking at milk production, milk composition, methane, and I'm showing here part of the data. That's what the ration that was fed. Either cows received no flax or about 10% of flax in the ration. The actual amount of flax was about 4.2 pounds per day per cow. The ration was formulated to contain about 40% of pasture and TMR. So talking about 40% of pasture and 6% of TMR. The TMR was about 25% of baleage, 33 or so percent of grain, and part of the organic grain meal here was replaced with flax. The organic grain meal was basically corn, soy-based grain, and there was some liquid molasses as well. So that's the ration, just showing here the nutrient composition of the ration. What I want to emphasize here, 2 things. One, if you see the crude fat, it's higher with flax, 3.8 to 6.4% fat in the ration, again, because of flax, and also alpha-linolenic acid higher in the ration with flax. However, that's why pasture in general lead to high levels of omega-3. You see pasture only, that's only pasture, is about 47% of the total fatty acids in pasture is basically alpha-linolenic acid or the omega-3, even higher than in flax. So you can see why pasture-based milk would be higher in those omega-3 fatty acids. In terms of milk production, at this time, we didn't see any negative impact of feeding flax, about 10%. You can see in green the control ration, and the blue, the 10% flax. You can see the milk production, it varies over the season. There is some fluctuations, as you can see. However, there is no treatment effect. If you see milk fat content, the same, there's some variation monthly, but no actual impact of treatments on milk fat content, the same for milk protein content. As you can see in this slide, again, you see variations during the grazing season, but not a treatment effect. In terms of milk fatty acids, we saw some things, even though we did not see a effect of flax on CLA, which is showing here in red. So either the pasture, the no flax ration and the flax ration, there's no difference. However, the omega-3, which is showing green here, was higher in cows that were fed flax, and the omega-6 decrease as well in cows that were fed flax. So if you see the omega-6 to omega-3 ratio, you have about a 100% reduction in cows that were fed flax, and that ratio was about 1.5, a little bit higher than the ratio during the winter season that was like almost a little bit over 1. So if you compare data with the literature, this is a recent study that was published last year. That's the ratio of omega-6 and omega-3 fatty acids, and also the polyunsaturated fatty acids and saturated fatty acids in organic and conventional retail milk from different countries, Denmark, Sweden, Switzerland, United Kingdom, United States. I want to just to focus here on the organic column. So you see those ratios, and you can see that our study it would be basically within that. I mean, within the lowest ones, we have 1 and 1.5, so it would be similar to milk like in Switzerland or even the one of the Kingdom, but higher, than the other countries. In terms of methane emissions during the grazing season, we're using the green feed gas quantification system. That's equipment that is a company that designed this equipment in South Dakota. Basically, you have cows visiting this unit up to 4 or 5 times during the day. Their cows are attracted by a bait. Basically, it's the feed, some grain that's dropped. That is, cows are basically wear RFID that identify them. Then it drops automatically about a cup of feed every 30, 40 seconds. You can set up that as you wish. The system can be used in a barn, as you can see here in your right, or in the field, in the pasture. And basically, there is a methane and CO2 and even oxygen sensors now, and you can actually get those data almost like real time. So in this study, we have over 100 days, so you have over 4,000 visits or so. In terms of methane emissions, that data it was not similar to the in vitro. The in vitro have a decrease in methane. Here, we did not see a decrease in methane. There is, as you can see clearly, some variation in methane emissions during the grazing season. However, there is no effect of diet. Either feeding flax or no flax did not change methane emission, even though numerically you can see that at some occasions, cows that are fed flax, which is in blue here, the blue columns, you can see that there is a reduction in methane, numerically, not statistically. In terms of income over feeding costs, is not surprised at this time that there was relatively similar during the grazing season. Again, we did not see a drop in components, so in milk production in cows that were fed flax. Here in the right end, you can see the cost that we use to make this analysis. But again, at this time, with 10% of flax in the ration during the grazing season, we did not see major difference in income over feeding costs. So some of the take-home message here, so I leave some time for questions. Feeding ground flax decreased milk production, milk components during the winter season. However, higher levels of ground flax, I'm talking about here 10 to 15%, really result in greatest milk omega-3 and CLAs and lowest omega-6 to omega-3 ratios. During the summer, we basically saw no negative impact of feeding flax on milk production and composition, but we saw decrease actually in the omega-3 to omega-3 ratios. So that was also we have more omega-3 on the cows that were fed flax. Economic analysis, as you saw, is very important to determine utilization of flax. That is also motivation for markets. Right now, feeding flax is quite expensive. There would need to be some sort of incentive in terms of to cover those costs, considering that you can actually have very high levels of omega-3 in milk and CLAs as well, at least during the winter season. So with that, I would like to acknowledge, folks that have been in my lab and the students, New Hampshire Agriculture Experimental Station for the support of the facilities, eOrganic and eExtension for facilitating this and this webinar, AgMotion that donate the flax that was used in this study, and also the funding agents, the USDA, NIFA, under the Organic Agricultural Research and Extension Initiative to fund this whole project. With that, I'll go back to Deb or Alice for the questions. Thank you.
Great. Thank you, Andre. Really appreciate it. Okay, so now for the remainder of our time together, we're going to have Q&A. I'll be reading the questions out loud to both Heather and Andre, and we'll just respond to as many as we have time for, okay? And there are already some questions in the queue, so we'll just dig right in. Let's see, Heather, you talked about early planting versus later planting. The question was, if you plant earlier, is there a danger of frost damaging the flax plants?
We have not seen any issue with that. They are pretty hardy. I'm sure if it gets, below 0, it probably would definitely hit back the plants. But we've reliably planted the same time we would plant winter grains and have not had an issue with any dieback. So
great.
We've had some pretty cold temperatures even this year, so 17 degrees.
That's cold. We have quite a few questions about grazing flax. Do people graze the flax, or do you have to grind it up?
Oh, sorry. Yeah. So do people graze flax? I've heard about folks using flax in cover crop mixtures to diversify the mixture. If everybody remembers what I said at the beginning, this is a fiber crop. So the digestibility of it, it's super, you can't break it, like pull and tug on it with your hands and get it to break when it's, once it's floured. So it's got a lot of fiber in it and a lot of lignin. So I don't really see where it would make a really good forage crop unless you're looking for a lot of fiber that's probably not very digestible. But Andre, I don't know if you have experience with that, but.
No, I don't have it, but I agree with you with with that high level of fiber and lignification would be a challenge.
So the seed must be ground for uptake, or can you feed the seed whole?
Yes, you can feed the seed whole, and there is experiments that are showing still positive impacts of that on the milk fatty acids. However, if it's broken, you likely would have a better impact on the omega-3 and CLAs, basically. So the seed is very small, so it may pass through the tract when it's not somehow either some sort of processing, even though, as I said, there is some studies out there that would show still positive impacts on omega-3s and even CLAs when they're fed whole.
Okay, great. Another question for you, Andre. Is there any reasonable explanation for the difference in results between methane emissions between the two major studies reviewed? Is it the diet?
Yeah, I would say that the diet, it's pasture, I would expect to be much more digestible than baleage, that was a major forage that was fed during the winter. Also, I think that could, cause this difference in methane emissions between both. The rations were also different. So the basal ration, and the major difference was pasture versus baleage. So I would say that has an impact on why you saw a response during the winter and not a response during the summer. Another thing, during the winter, we went up to the 15% level, which really also, you could see that level was the one that really was more effective in dropping the methane.
Okay, great. Question for you, Heather. In terms of growing possibilities, this question comes from North Carolina. How far south have you seen flax grown successfully? I know you're up here in the Northeast, so you might.
Yeah, I mean, I wouldn't imagine that it would grow very successfully down in North Carolina. I think that I don't know. That's a good question. I honestly don't have a good answer for that. It's traditionally, a crop that's grown in the far northern regions because flowering is so susceptible to heat. Even here sometimes, if we plant a little bit too late, we see major reductions in yield. But I don't have a, hard answer on that.
Okay, fair enough. And then another question about sowing the crop. Can you broadcast the seed or bulk spread the seed?
Yeah, you could. I think the challenge with any kind of broadcasting of seed is making sure that you have, even germination, and so that once you broadcast it, that you use a cultipacker or something to that, of that nature to press the seed into the ground firmly. Sometimes with small grains, we see uneven emergence when we broadcast seed. So, that would just be the limitation to broadcast seeding.
Great. Andre, do you have any information on feeding flaxseed to chickens, rabbits, or pigs?
No, I mean, I don't have it. No, I don't have it, that information. But what I know is you don't want to feed lots of oil or fat to simple stomach animals. I'm talking about here the rabbits or chickens, because a ruminant, they can really saturate a lot of those unsaturated fatty acids that are present in flax, and non-ruminant animals cannot. So if you're talking about quality of the meat, that could have an impact. But again, I don't know much of that in terms of all the species, but I'll be at least not feeding a lot.
Okay, fair enough. So using your economic benchmarks for milk costs, what would a break-even incentive need to be per hundredweight to produce flax supplemented feed? That's a good question.
That's a good question for Bob Parson. I'll see if I can find him. I honestly, I don't know exactly to answer that question. Based on those income over feeding costs, you can see that flax coming from outside of Northeast here to feed at those levels that we fed, primarily the 10 and 15%, I don't think that would be economically viable. without, as was in the question, without some sort of incentive to naturally producing high omega-3 milk year-round. Because during the summer, you can see, even though, you could see that still increase, but my rations here was not 100% pasture. Maybe rations with 100% pasture will likely not need any supplementation because naturally it's producing a lot of those omega-3. However, when transition from the winter, that's another consideration. So I don't know, how much the industry or if there is any market at this point that will, make incentives. I know that there is incentives for grass-fed milk, and grass-fed milk, it's already high in omega-3. Yeah, but there would need to have some sort of incentive to cover. We fed flax in 10 farms for 2 years. That were the commercial farms, organic farms that were participating in this study. And we fed at 5%, which is about 2.5 pounds. And they realized increase in omega-3s and CLAs as well, even with the 5% level or 2-3 pounds. So again, those omega-3s, it can be increased. The CLAs can be increased with flax, but I'm not sure how much the industry or the processors would be willing to, to come up and discuss this issue in terms of to break even that cost. Yeah.
Well, great. Unfortunately, we are out of time, but I'd like to thank all of you for your questions and remind you that you can find an archive of today's session, recordings of our other webinars, as well as articles, videos, and more at eextension.org/organic_production. Andre and Heather, thank you very much for spending time with us today, and thank you all for coming.